The terror of tornadoes has intrigued many for millennia. As we unravel the mysteries of these atmospheric giants, from their dramatic birth to the science behind their jaw-dropping formations, we explore how these menacing anomalies form and when their destructive, unforgiving forces are most likely to appear. Picture yourself looking out of a car window on a hot summer afternoon, while your eye catches a dark, unusually tall cloud formation off in the distance. You fail to realize what's forming deep within. The belly of this beast will soon spawn a powerful supercell thunderstorm capable of spawning any number of destructive weather phenomena and growing rapidly in size. As warm, moist air rises, cold air begins to descend. The cloud tops rapidly rise, bringing an onslaught of torrential rain or worse, hail. This mix of warm and cold air may result in a horizontally spinning column of air inside the storm. If there's a strong enough downdraft, the column may shift vertically, birthing the formation of anything on the scale of a short-lived, whimsical cloud rotation to a monstrous F5 tornado. An atmospheric freight train capable of wiping out entire towns and leveling entire cities within minutes. For a tornado to form, we must also consider ground level conditions. While cool air from the storm descends, warm air at ground level rises. When these air systems meet, the air near the ground starts to spin. As the ground level whirlwind draws closer to the storm's axis of rotation, it begins to spin more rapidly, a phenomenon known as the conservation of angular momentum. This is when the tornado visibly takes shape, transitioning from a harmless mix of wind and temperature gradients into a breathtaking, potentially life-threatening system. Tornadoes remain among the most potent and enigmatic weather phenomena. While the intricacies of their birth are still under scientific scrutiny, some fundamental components are almost guaranteed to lead to their formation. Supercells come to life due to a meteorological tug-of-war known as wind shear. This captivating dance involves winds traveling at varying speeds and directions at different altitudes. Most tornadoes take their first breath at the core of a supercell, a storm category famous for its vigorous upward spirals of air. Since supercells breathe in massive volumes of warm, moisture-laden air, they form a wall cloud, creating prime conditions for tornadic activity. As air converges fervently beneath the looming wall cloud, the vortex tightens its grip and spins with ever-increasing speed. Then, in a climactic display of power, the rotation reaches from the Earth's surface to the skies above, where a tornado is born. Yet, not every supercell possesses the magic to conjure this meteorological masterpiece, for it requires the precise alignment of air and surface conditions to complete this awe-inspiring act of nature. When a tornado touches the ground, its formation often darkens and turns more menacing. Its ferocious winds pick up dust, debris, and, if the wind speeds are fast enough, cows, cars, roofs, mobile homes, trees, and anything else not well anchored to the ground. A powerful tornado can lift massive objects, like semi-trucks, dropping them miles away. The United States frequently finds itself at the epicenter of global tornadic activity. Each year, the National Weather Service records approximately 1,000 tornadoes, resulting in around 240 deaths and a staggering $14 million in damages. The tornado season in the US typically unleashes its fury from March through June. As reported by Fox Weather from 1991 to 2020, the month of May witnessed the most tornadic activity in the US, at its peak with the highest average monthly occurrence of tornadoes. The term Tornado Alley was coined by American meteorologists to describe the most favored route of tornadoes in the central US. This corridor cuts through the heart of the Great Plains, stretching from North Dakota and Minnesota down to Nebraska, Iowa, Kansas, and Texas, offering a thoroughfare for most tornadoes. But tornadoes do not form exclusively in the United States. They are also frequent visitors in other corners of the world, including Argentina, India, and Japan. For example, in April 2021, residents in the southern reaches of Argentina's Mendoza province were treated to a sighting of a frightening tornado. With quick thinking, locals captured the spinning vortex on camera and shared the awe-inspiring video on social media. Fortunately, this tornado's path spared any buildings, leaving no damage or injuries. Following the tornado's dramatic exit, the skies unleashed rain accompanied by hail, concluding this remarkable meteorological event. Tornadoes can happen at any time of the year, but often peak during tornado season, when the United States sees the most tornadoes out of the year. In general, tornado season in the southern plains, Kansas, Oklahoma, and Texas, see more tornadoes from May to early June. However, on the Gulf Coast, tornadoes are most common during early spring. Northern states and areas of the upper Midwest, Iowa, Minnesota, Nebraska, and North or South Dakota, have peak tornado season in June or July. Because spring is a time of transition from cooler temperatures to warmer weather, it creates the optimal, unstable air conditions for tornadic activity throughout the country. Although tornadoes are statistically more likely to occur between 3 and 9 p.m., it's important to note that they have been known to materialize at any hour of the day or night, reminding us of their unpredictable and relentless nature. NOAA's GOES-R series weather satellites have significantly advanced the detecting and assessing of storms with tornadic potential compared to their predecessors. These satellites offer enhanced capabilities for rapidly monitoring cloud movements, allowing for early identification of severe storms as they begin to form. They excel at delving deeper into the inner workings of these cloud systems, providing valuable insights into critical characteristics that signify a severe storm. The GOES-R series satellites excel in their ability to observe lightning activity, shadow top properties, and cloud motion. These precise measurements contribute to a more accurate assessment of a cloud's potential to generate tornadoes. They also provide valuable information regarding the type and severity of tornadoes that may be produced. Ready to continue your journey with us and witness more jaw-dropping tornado footage? Click the videos on the screen and we'll see you there.